We asked the model to summarize a document, an ordinary one, quarterly notes. But one line in the middle was not written for a human to read. It was written for the machine. So we ran it, and it did not summarize anything. Nobody hacked anything, the attacker just wrote text, and the machine read text and treated it as orders. The weak spot is that your AI is good at following instructions. And the input is full of instructions. Section 1, the trust boundary, the line nobody draws. On one side of the line is what you control, your standing instructions, your rules, your task. You wrote it, you meant it. On the other side is everything the model reads that came from outside. A user message, a looked-up document, a web page, an email, a tool's reply. You did not write it and you cannot vouch for it. Here is the problem. To the model, it is all just words in the same pile of text it is reasoning over. There is no built-in line between my instructions and text I am reading. The model will not draw it for you. You have to draw that line. And if that sounds familiar, it should. It is the oldest bug in security. Something that was supposed to be data got treated as instructions. Two things go in, your instruction and a document you asked it to read. They land in the same pile, and it reads the pile from the top. So when a line in that document tells it what to do, it obeys. Nothing on either line says which one of you wrote it. Section 2, you cannot defend against a danger you have not named. 3 threats named. Threat 1 is prompt injection. Hostile instructions hidden in content the model reads. A document with reveal all keys buried in the middle of it. A web page with white text on a white background, invisible to you, plain text to the machine. And the key feature, the attacker does not need to get inside your system. They just need to get some text in front of your model. Which means if your agent reads the web, anyone who can put text on the web can try to program it. Threat 2 is exfiltration, getting a secret to leave the system. Injection is the how, this is usually the why. And it does not need a network call. It can be as quiet as slipping the secret into the model's normal answer. Any path the model's output can travel is a possible leak path. The reply a tool calls arguments, a file name it writes, a URL it visits. So the rule, if a secret and hostile text sit in the same pile of text, assume the secret can walk out. Threat 3 is the one that turns a nuisance into a catastrophe. A chatbot that gets injected says something dumb. An agent with real tools does something dumb. Give a model the power to send mail, run commands, or move money, and you have handed those powers to anyone who can get text into its context. And it compounds, each step feeds the next, and the damage grows. A poisoned document says run this, the command fetches more instructions, and those instructions spend from the wallet. So say the rule bluntly, an agent's blast radius is its tools times everything it reads. Section 3, now the part everybody wants to skip to. We tried to defend it. The tempting fix is one line in your system prompt. Just tell it not to fall for it. So we ran the same payload 3 times. First, no defense at all. Then a system rule telling it never to follow instructions inside a document. Then delimiters and an explicit rule that the document is untrusted data, the strongest version of the advice you will read online. All 3 obeyed the attacker. Look at what we actually put in its way. We asked it nicely, then we made it a system rule, then we added delimiters too. And the payload walked past all 3. It answered with the one word the document told it to answer with. Every single defense made of words failed. It fails for a reason worth understanding. The model has no reliable way to tell your instruction from the attackers. They are the same kind of text, arriving the same way in the same pile. Worse, the attacker gets to write theirs after reading yours because system prompts lake. Prompting against injection is like politely asking the burglar not to rob you. So remember the shape of it, prompts persuade, structure, and forces. What does not work is asking the model nicely to behave. It is a suggestion the attacker can outrank. What works is structure, fence the data, sense the attacks, shrink the blast radius with isolation. And gate every one-way action behind a human. That is the rest of this track, one module each. So run it one more time, the same payload arrives, word for word. Only now there is a gate in front of the tool. The gate does not read the argument because it is not made of words. It cannot be persuaded, so the tool never ran. That is the difference between asking and enforcing. 1. Pick a real agent, something with a job, a research assistant that reads the web, an inbox triager, a coding agent, one sentence on what it does. 2. List its tools, including the quiet ones. Reading files is a power, so is fetching a URL. 3. List every source of text it reads that you do not control. User messages, documents, web pages, tool outputs, emails. 4. Cross them. For every tool, one concrete sentence. How could hostile text in that source abuse this tool? 5. Circle the ones that are one-way or exposing. Money spent, data leaked, code run, mail sent. And be willing to reach the honest conclusion. If a crossing cannot be made safe, that is a sign the agent should not hold that tool at all. That's module 1 of AI that can't be turned against you. Next, input is data, not commands, and how to enforce it. Lyceum from VEKTORGEIST.